welcome to January 2011 Core 1. This is Core 1. So we're going to go through these questions at about a mark a minute. I'm going to try and keep to that, and let's see how we get on. So we start with a differentiation question, a differential. Find dy over dx. So here is this long y equation. Let's try and change it into dy dx. So let's look at this. Y equals 13 plus 18x plus 3x squared minus 4x cubed. So what can we do with that? So when we are differentiating, what we're going to try and do is times this power here by this number in front, and then drop that power down by 1, so take 1 away from that power. So you'll get the idea as we go along. So the y changes into dy over dx, the difference in y over the difference in x. So this 13 has a power of effectively x to the 0. So 0 times by 13 is nothing, so we effectively just get rid of that. Anything without an x, we just write that down as a 0, or you don't even need to write it down, you don't have to. Then this 18, this is a little power 1 here, so 1 times 18 is 18, and then that becomes times x to the 0. X to the 0 is equal to 1, so 1 times 18 is 18, so we've effectively 1 times 18, put it there. Then we get a little bit of a nicer one, so 2 times by 3 is 6, so we're going to get 6x, and then drop this power down. That's a little power 1 there. You can imagine it there, we don't have to write it in there. And then minus 4 times 3 is minus 12x, and then this is going to be a 2 here. So I think you get the pattern there. And then, just to write it out neat, you could put all the the biggest powers on the left. It's normally the way that they tend to do it. So you have minus 12x squared plus 6x plus 18, and that's going to be our final answer there. So let's move on to question B. So show that point P is a stationary point. So this is very important here, this stationary point. So a stationary point, if I just draw some arbitrary, I'm just going to draw some arbitrary kind of graph here. Let me choose green to do this. So if we just have some arbitrary thing coming up, the stationary points are the points here and here where the direction changes, or where the gradient, let me write this down, where the gradient is equal to 0. The gradient and dy dx are the same thing. Dy dx means change in y over change in x. So what we're looking for here is to put a big 0 here. So let's do that. Let's do that in green. So we're going to say for question B, 0 is equal to minus 12x squared plus 6x plus 18. So what are we going to do here? Well, we'll do what we normally do with a situation like this, just try and find two values for x in brackets and then two real values for x where we can. So what I'm going to do is divide everything by minus 2 to try and get it in kind of easier numbers. So the 0 stays the same, and then we get 2x squared minus x divided everything. Did I say divide by everything by minus 2? I meant divide everything by minus 6. I think I said that wrong. So, and then we're going to have also here, we're going to have a minus 3. And then what can we do? Well, we look at this number and this number. I hope you've done this before because I'm going to go through it quite quickly. So we need two numbers that times together to make minus 6, because 2 times minus 3 is minus 6, and add together to make minus 1, because that's, let me use another colour for that. Let me use another colour. So this here, this is effectively a minus 1 in there, so we need two numbers that add together to make minus 1 in there. So what are the two numbers that times together to make minus 6? Well, we could have minus 3 and plus 2. That would fulfill this criteria here, because they times together to make minus 6. and when added together they do indeed make -1, so we have our criteria fulfilled. So let's write that in there. So we have 0 is equal to 2x squared plus 2x minus 3x minus 3. So you notice I haven't changed the value of this. This is the same thing, just written out kind of in a longer longhand version. And it's also worth mentioning, it doesn't matter which way around you put, oh hang on, it doesn't matter what way around you put these two terms, it's just easier to match the 3 with the 3, and you'll see why in a minute. So what I'm going to do now is factorize. So factorize. So take 2x out, take everything out of these two terms here. So these two terms here, take everything out that I can. So take 2x out, and then what am I left with? Left with x here, because 2x times x is 2x squared, and then plus 1 there, because 2x times by 1 is 2x. And then we have a -1, no, sorry, not -1, what am I talking about? -3. -3 is what we can take out of both these terms, and then we are left with x plus 1. No coincidence that these two brackets are the same. They have to be the same. They should be the same. If they're not, go back and change something, because you probably made a mistake or something's gone wrong earlier on. So make sure they're the same. And then what we have is 0 is equal to this term and this term put together, so 2x minus 3, and then this bracket here, which should be the same as this bracket here, x plus 1. And that's how we get our two brackets there out of this one up here. Some people can just look at that and go, I can see what it is, but for those who can't, and I mean I can't, so that's the real, the real algebraic method. And then what do we have? Well, we have x is equal to -1, because here we have x plus 1 equals 0, so then you have, if you have x plus 1 equals 0, then you have take away 1 from both sides and you get x is equal to -1. That's how you do that. Then we'll do the same thing with the other one. Let's go for pink. So then we have 2x minus 3 is equal to 0, so then we have 2x is equal to 3, and then x is equal to 3 over 2. So x is equal to 3 over 2. You should be able to do that bit in your head, but if you don't want to, just write it out like that. It's not a problem. So then we have here, we have our two stationary points. So one of them, as the question says, is point P, because point P is where x is equal to -1. So what it wants us to do is find the other value of x where the curve has a stationary point. So one of these where the gradient is 0. And we have done that. We found x is equal to 3 over 2. So in our situation here, we've got, if you imagine one of the, maybe the lower point is around, I don't know, here somewhere, where this is 3 over 2, and then our -1 here, this is our higher point. So obviously this is not a correct graph. This is just to show you. So let's move on. I think I'm talking too much now. So here, find the second differential at the point P. So let's do it generally first. Let me draw a box around that. So question C, part 1, part I. Let's do that. So the second differential, we find that the same way that we find the first one, by doing that thing with the indices going down by 1 every time. So let's take this here. Let's take that and do the same thing to it. So what are we going to get? Well, we're going to get -12 times 2, so we're going to get, hang on, let me write this down first, d2y over dx squared. It's going to be equal to, so here we go, so -12 times 2 is -24x, and then this comes down by 1, so that's x to the 1, so we don't need to write that in. Let's go for a new colour. And then 6x, so this power is going to, 1 times 6, and then the power is going to drop down, so we're going to get a +6. And then this 18, well, this has no x, so it's 0 times 18, which is 0, so we can just kind of strike that one out. So then there we have it. That's what our second differential is, and they want it at the point P, and they've told us the point P, x is equal to -1 at the point P. So let's put in -1 into that. So we can say at p d2y over dx squared is equal to 24, or minus 24 times by minus 1 is going to be 24, and then plus 6 is going to be 30. And that's all we have to write down for those 3 marks there, which I quite like that. I think that's quite kind of easy marks in that situation almost. And then let's go down a bit more. I don't want to cut off the question completely because we have to look at it. So hence or otherwise. So hence or otherwise normally means use part 1, because you just worked out something that helps you work out this bit. So determine whether it's a maximum or minimum point. So this is a little bit counterintuitive, but I'm going to show you on this one that we've already drawn. So this point here is what's known as a maximum point, or a local maximum, but more commonly just a maximum point there, because it peaks there and then it goes back down again. And this here, with the same logic, is a minimum point, or a local minimum point. So a minimum within these bounds of this bit of the curve here. So we have a maximum and a minimum. And what we want to know is whether p at -1, so somewhere around here, obviously not this curve. So our -1 value, is that a minimum, or is this the minimum, this 3 over 2? So what we can do then is we can say, let's do part 2 or part II. So let's say that 30, our second differential at the point P, at the point that we care about, 30 is greater than 0. If we put 3 over 2, or maybe you can try this yourself if you want, put 3 over 2 into there, you'll get something that is less than 0, but 30 is greater than 0. Therefore, P is a minimum point. It's a bit counterintuitive. You'd think, because it's a high number, it would be a maximum, but it isn't. It's a minimum point. And that is the end of the question. I think I've gone on a bit too long in this one. I'll make the next one shorter. See you in the next one.